All right, guys, we're moving into section 4.6. Section 4.6 deals with arithmetic sequences. So we're in the same theme of linear, but we're into a new topic area, which is arithmetic sequences. So an arithmetic sequence, and make sure that you write down this definition. In an arithmetic sequence, the difference between each pair of consecutive terms is the same. This difference is called the common difference. Each term is found by adding the common difference to the previous term. So when we're dealing with an arithmetic sequence, we have a common difference, meaning that we're going up or down by the same amount each time. Okay, an arithmetic sequence follows a linear pattern. It has that common difference there. So we can see in the example that's shown here, we're adding 5 each time. That plus 5 that we see right here would be our common difference. And because we're going up by the same amount each time, that means that we have an arithmetic sequence here. So write the next 3 terms in the arithmetic sequence that is shown. So we can see here, do we have a common difference? We do. We're going down by 7 each time. So in this particular example, our common difference can be negative. And in this case, it is negative 7. So when we think about the next 3 terms, we have to subtract 7 3 more times. So if I subtract 7 right here, I'm going to get negative 35. So my next 3 terms are going to be negative 35. Subtract another 7, and you're going to get to negative 42. And subtract another 7, and you're going to get to negative 49. So you're just continuing the pattern. When they ask you to find the next 3 terms, look at the pattern that's shown there, and then continue that pattern as you go forward. I'll do the first example in here, okay? We might take a look at it in class as well, but you'll at least already have it down. So you want to write down this example. We're looking at what the common difference is here. We're adding 12 each time. So if we continue down this pattern, keep adding 12, you're going to get 36, 48, and 60 as the next 3 terms. We'll take a look at those more challenging examples, number 2 and 3, in class. All right, now you're asked to graph the arithmetic sequence. You'll notice here that they don't really give you points. They just kind of give you the values. So we can really think of this as the point 1, 4, because this is my first term. So the x value would represent the term number. So 1, 4, and then this would be 2, 8. This would be 3, 12. And this would be 4, 16. So x is the term number in your sequence. And then you would just go ahead and you would graph this. So you have 1, 4, which would be here. You have 2, 8, which would be here. You have 3, 12, which would be off my graph, but up here. And then you have 4, 16, which would be off my graph, but there. You'll notice here, like I said before, that it creates a line. Okay, because arithmetic sequences are linear. When graphed. So if we continue the pattern, we can see that the 5th term would be 20 because we're going up by 4 each time. The 6th term would be 24, and so on and so forth. Let's look at the next example. Does the graph represent an arithmetic sequence? Explain. So let's take a look here. In essence, what we're looking at, does this create a line? Do we have a constant rate of change? Well, obviously, your term numbers are going up by 1 each time. And let's look at the y values. Down by 3, down by 3, down by 3. Yes, this is an arithmetic sequence. Why is it an arithmetic sequence? Because we have a common difference of negative 3. And it's a good idea to write down this graph as well as the explanation as to why it is an arithmetic sequence. We'll look at these examples in class. Our next core concept here, the equation for an arithmetic sequence, which is very important. Make sure that you write it right here. Sometimes we write it with the D in front, but I want to make sure if you're doing that, you get your order of operations correct. So you might see it written in this manner right here. A sub n is equal to a sub 1 plus d times n minus 1. Now, what do each of these values represent? A sub n represents the term that we're talking about. A sub 1, this is a key part here, is the first term. D is your common difference. Those values will always be plugged in when you're writing the formula for an arithmetic sequence. Make sure that you copy this down. A sub 1 represents the first term, and D represents the common difference. Now, eventually, you might be asked to plug something in for n. N would represent the term number. And again, it doesn't matter if you put the D out in the back, like seen here, or the D in the front. So let's take a look at this example. There are two parts to this example. First, it says write an equation for the nth term. That's part A. Then it says find a sub 50. So when you're asked to write our equation, that is our general form. A sub n is equal to a sub 1 plus n minus 1 times d. So what is a sub 1? Let's write down what each part is. A sub 1 is our first term. In this case, it's 14. What is my common difference? I'm going down by 3 each time. My common difference is negative 3. So when I write my general form, my equation for this arithmetic sequence, it's going to look like this. A sub n is equal to, we're plugging in only values for a sub 1 and d. So 14 plus n minus 1 times negative 3. Or if you want to write it, 14 plus negative 3 times n minus 1. Now, the reason the book doesn't show it that way is because people get in the habit of combining these two values, which you should not be doing. This is order of operations we need to distribute. So we can actually clean this up a little bit. We can distribute. I'm going to do it in red. So we can distribute this and get a sub n is equal to 14. Negative 3 times n is going to be negative 3n. Negative 3 times negative 1 is going to be a positive 3. And then I can combine my like terms here with my 14 and my 3 to get a sub n is equal to 17 minus 3n. So this is really the best answer right here. The ones that we see above are not simplified. And again, you get the same thing here, 14 minus 3n plus 3. And then you can combine your like terms and get 17 minus 3n. Okay? But this right here is our general form or our equation for the nth term. Now, the next part that we're being asked is asking us, okay, now you have your equation. Now find a sub 50. So now we have to find a sub 50, which means find the 50th term by taking 50, and that's our n value, plugging it in for n into our equation. So a sub 50 is going to be equal to 17 minus 3 times 50. So what is a sub 50? AKA, what is our 50th term? 17 minus 150. A sub 50 is equal to negative 133. So there are two parts to our answer here. Finding the equation, which we've done right here, and then finding our 50th term, which we've done right here. Okay, two parts to this. Let's do one more example here. I'm going to do the first example where it says find the equation for the nth term and then find a sub 25. So what do I need? I need to know my first term, a sub 1, which is 4. Easy common difference here. We're just adding 1 each time. So my common difference d is equal to 1. So remember, a sub n is equal to a sub 1 plus n minus 1, and then the d. So our general form, a sub n is equal to 4 plus n minus 1 times 1. Well, I'm just distributing a 1 here. So a sub n is equal to 4 plus n minus 1. A sub n is equal to, combine your like terms, 3 plus n. There's my form of my equation. Now I need to find a sub 25 by plugging in 25 plus n, or for n rather. So a sub n is equal to 3 plus 25. And a sub 25 here would be equal to 28. So your 25th term is 28. All right, and those are the two parts that you need to include. We'll go through examples 9 and 10 in class. All right, example 5 here. Online bidding for a purse increases by $5 for each bid after an initial bid of $60. So they've given us that table that's right there. So we're going to write the function. Remember, a sub n is equal to a sub 1 plus, in parentheses, n minus 1 times d. So my first term here, a sub 1 is equal to 60. Our common difference, we're going up by 5 each time. So my common difference d is 5. So let's write that function. A sub n is equal to, plug in the 60, plus, and then in parentheses, n minus 1 times 5. We're going to distribute that 5 so we can clean this up a little bit. A sub n is equal to 60 plus. Don't forget to distribute that 5 to both parts. I've noticed that on some of your quizzes and tests that you guys aren't distributing it to both parts. So plus 5n minus 5. Combine your like terms here and here. 60 minus 5 is 55. So we're going to get a sub n is equal to 55 plus 5n. There's our equation right there. Graphing it, I'm not going to go through that step. That'd be pretty easy. Just graph the points 1, 60, 2, 65, 3, 70, 4, 75. Here they're saying, okay, the winning bid is 105. How many bids did it take? So we're trying to solve for n here in our function, and we're plugging in 105 for a sub n. So 105 is equal to 55 plus 5n. And now you're just solving an equation. Subtract 55. We're solving for n, which is the number of bids. 105 minus 55 is 50. So 50 is equal to 5n. Divide by 5. Doesn't want me to. And you get n is equal to 10. So it took 10 bids to get to a bid of 105. All right, so the key thing in this section is making sure that you understand that an arithmetic sequence just follows that linear pattern. We have our formula for an arithmetic sequence that's right here. Make sure that you have that down. Make sure that you know what a sub 1 represents, your first term. Make sure you know what d represents, the common difference. From there, pretty straightforward, and I'll see you guys in class.